Hi guys. So this video is going to be on padding oracle attack because last semester padding oracle was a pretty common issue in cryptography. So I've made this video on the theory behind padding oracle attack to just help you guys out with understanding the principle behind it. So first, we'll do a brief review of how padding works in AES. So if you remember, with PKCS number 7 padding, we put a number of bytes representing the value to pad, and we repeat that the number of times we want to pad it. So in this first example, we want to pad 11 bytes. So we have 11 bytes of hex 0b, which is 11. So when we unpad this block, we end up with the byte string of hello. Okay, but if we change it, instead of putting hex 0b as our byte, we put hex 0c as our byte, then we can't unpad it because now we're expecting 12 bytes of padding, but we only have 11. So whatever is unpadding our block can potentially throw an error. And if we have our last byte as a hex 01, then we see, because we have exactly 1 byte of it, or because we have 1 byte of it, we can unpad that 1 byte, and everything else we treat as part of the actual string. So we end up with hello repeat with a bunch of hex 0b's repeated after it. Okay, what if we have no padding bytes? Then, because of the way PKCS number 7 padding works, this also doesn't work because we always need to have padding bytes. So in order to fix this issue, we actually need to add an entire new block of padding bytes after our actual block of text, and this will unpad correctly. Okay, so how can we take advantage of this unpadding behavior? So let's say we have this string. And we have no idea what's in the string, but if we can see that when we use this string and we send it into the worker to have it unpad, that the worker throws an error, then we can tell this is not padded. So what if we somehow manipulated this string to instead have the last byte be the letter A? Then it's still not going to work because the padding is expecting, or it's expecting padding, and A is not a padding byte. Okay, what if we make our last byte a hex 02? Then it still isn't going to work because we're expecting 2 bytes of 2-byte padding, but in this case we only have 1 byte, so it will also cause the unpad to fail. And finally, if we do have the correct padding amount, which is a hex 01, then we will have a correctly padded block, and we can therefore conclude that through a process that we'll go over in the next slides, that we can figure out that the original byte was actually an exclamation mark. And this is just a brief review. So this was a slide in the lecture videos, and this is just about cipher blockchaining. So the way that it works is we XOR the previous block of ciphertext with the plain text of the current block we want to encrypt. And because of the way this works, we can manipulate the previous block to make it so that we XOR the plain text with whatever we want to. So yeah. And before you start working on the padding oracle attack challenges, you should have done the previous CBC resizing and so on challenges. So you should have a general idea of how this mechanism should work. So now we have this mystery block of ciphertext. So how can we figure out what this very last byte here is? So one thing we can do is we can manipulate it so that we XOR this block with hex 00. and we see this is going to fail, and presumably there will be an exception thrown, or in these challenges, it prints out the error. So that means that this will not work to unpad it correctly. So what if we try XORing it with hex 0, 1? This also fails, and we keep repeating it until eventually we get to hex 2, 0, and we find that it does unpad correctly, which means that we can conclude that this last byte, when we XOR it with hex 2, 0, we get a 1 byte padding. And so therefore, the 1 byte padding XORed with hex 2, 0 should give us the string that, or the byte that is at our question mark value. So therefore, the last byte must be a period. So now we have the last byte. How can we get the byte before that? So we can do something very similar to what we did in the previous, or did for the previous byte. So instead of XORing with a hex 0, 0, now we're doing it so that the last 2 bytes are being XORed as a hex 0, 0, hex 2C, because period XOR with 2C will also give us a hex 0, 2, because now we're trying to aim for 2 bytes of padding. So if we keep repeating this, we can eventually see that when we XOR it with hex 66 and then hex 2C, it will unpad correctly. So that means that our question mark period XOR with hex 66, hex 2C will become hex 02, hex 02. So therefore, we now know that the last 2 bytes are D period. Okay, and now how do we do the block before that? So we do something very similar again. So this time we're doing question mark D period XOR with hex 00, hex 67, hex 2D, because D XORed with hex 67 will give us the 03 that we need for 3 bytes of padding, and the period XORed with 2D will give us the 03 that we need for the 3 bytes of padding. So then we can repeat this until we get a successful unpad. And so we now find out that when we XOR with hex 71, hex 67, hex 2D, we get the correct 3 padding bytes of hex 03, hex 03, hex 03. So therefore, our last 3 bytes are hex, or not hex, the bytes RD period. And so we can just keep doing this for the rest of the block. So we don't know what this is. We repeat until we figure out something that unpads correctly. And so we get that this is the letter O. And we can keep doing this. This is letter W. This is S. This is S. This is A. This is P. This is space. This is comma. This is O. This is L. This is L. This is E. And this is H. And now we have the text of the entire block. And we just did this by repeatedly sending in different XORs until we get something that unpads correctly and slowly build up what we know about this block. Yeah, so hopefully this video has given you guys a better understanding of the concept behind AES ECB, not ECB, CBC POA. So you'll be able to start writing a code to actually solve the challenges. Good luck.